Hello everyone, we continue doing trigonometry. This is all about combined questions. I may say that right now it's going to be easy, medium, low. This part 3, all about trigonometric ratios. It's right time to apply in like a bit more complicated problems than just for simple year 9. Alright, let's move next. So here is the problem 1 that we discussed before. Problem 2 we also discussed. Make sure you watch corresponding videos about that. And here is the problem 3. You're given a right angle triangle. You're given a segment AL, which is right there, and it's put from vertex A so that it will form BL segment with 6 centimeters, and you need to find sides CL and AC. Pause the video, try to do by your own, and let's see my short explanation for that. Alright, so in order to find CL, we definitely need to find BC somehow, right? So the first is all about how to find BC, and the second one, because you need to find AC. Obviously, once you found BC, you can find you'll be able to find AC. Okay, but the reason that for complexity for this problem is about nested triangles. So I will use the first triangle, which is small one, BLA, with the angle 34 degrees. This is smaller, okay, as part of the angle A. So we can freely find side BA or AB. Okay, so let's complete, because AB is their adjacent side to the angle 34, and we have 6 as the opposite side. We can use tangent rule. So this is adjacent side, so this is the opposite side. You remember tangent by definition is opposite over adjacent, which will form tangent of the given angle 34 degrees. Alright, what we're going to do, we just need to plug the values. 6 over adjacent side, which is unknown, let's mark as AB, will be equivalent to tan 34. I'm not going to calculate because I'll do it in one transaction and a final step. So we express AB from there. It's simply crisscross ratio, right? And AB from there is 6 over tan 34 degrees. Okay, so if you calculate that and round up to 2 decimal place, you'll get around 8.90 centimeters. So once we found AB side, we can work out the side BC. Alright, so let's do that. From the big triangle, which is ABC, so using triangle ABC, we'll express BC side as, again, opposite side to adjacent. So BC to AB will form tangent of 38 degrees. Okay, so we don't know AB, so we don't know BC. It's right time to find that. So BC is AB, which we recently found, times tan 38 degrees. Okay, so from there we can calculate BC. BC is 8.90 times tangent 38. That's pretty easy. Now let's try to calculate that. So let's have a look. 8.90 times tangent 38 degrees, in this case 6.95 degrees. So we've got 6.95, sorry, not degrees but centimeters. All right, so we found BC, and we will be able to find segment CL. It's not the side, actually. CL is just the segment line. Let's do that. So CL is simply 6.95, the whole BC side, minus segment 6 centimeter, which is LB. So we'll get 0.90 centimeters to 2 decimal places. Okay, so we found CL, and what about AC? How to find AC? For the AC, let me see, we can use an adjacent side, for example. We can use cos rule. So there are plenty of opportunities how to find AC. So AC is the height, so you can use Pythagoras, for example, first idea using Pythagoras. So AC squared is BC squared plus AB squared. So that's simple Pythagoras theorem. So you know BC is 6.95, you know AB, which you recently found. So I'll just demonstrate how it can be accomplished. So BC is 695 squared and AB squared is 8.9 squared. So, but I don't recommend to use Pythagoras. Instead, let's just simply calculate that. Square root of 695 squared and plus 8.90 approximately, because this is a rounded figure. So what I've got 1129 centimeters. Okay, but I don't recommend do that. I would better recommend to use still Trigs ratio because they work pretty fast. So let's see, for example, AC can be expressed through cos rule. Okay, so let's first express just cos by definition, if you like, and a big triangle. So cos 38 degrees, it's by definition adjacent side over height, right? Your adjacent side is AB, so you know that it's 8.9 over AC, which is height in this case. And you can express AC through 8.9 over cos 38. If you want, you can check and you will get the same answer, I'm pretty sure. So that's CL, that's AC. Of course, you can use several opportunities. You can use, for example, AC, you can express through sine. For example, in this case, you should take BC side, so that's why it's BC over height. Sorry, in this case, because you want to figure out AC, let's use sine rule just by definition. Our sine trigonometric ratios, sine 38, it's simply BC, which is in our case 695. So this is 695 is BC over unknowns AC. And again, you can easily express AC through that. So that's more about rearrangements, you know. So AC is 695 over sine 38. And that's how it can be done. All right. So that was the problem 3. I'm pretty sure it's really like medium level. So I'm gonna say even more, it's easier medium level. So if you know trigonometric ratios, it's not the problem for you. And in the next video, we'll consider problem 4. Pause the video, try to do by your own. In the next video, you'll see my explanations. Check it out, and don't forget to watch all other stuff that I have on my channel. That was Daniel Dallas, and peace.